Okay, so whether or not you will get addition or substitution, it's really simple. It depends on the leaving group. So previously we were talking about this whole thing, right? And the previous slide we were talking about the delta plus. This only affects the nucleophilic attack. Right? So this only affects this step whereby your nucleophile is going to attack. It only affects that step. Then once you get to once this is formed, actually it depends on X being a good leaving group, right? If that happens, then you can get substitution. If this X is bad leaving group, then it's not favorable for it to leave, so they'll both just stay there. Okay, great. So let's move on. Okay, so if your leaving group is methyl, right? Methyl, right? See, the ability of X to accept the electrons or stabilize the negative charge, right? So you want this to be a stable negative species. So how do you do that, right? It's either, again, by induction or resonance. Okay, same concepts. So your induction or your resonance. And induction can include like dispersing charge, right? And in a sense, that's what electron donating or withdrawing groups do, right? Resonance is, as said just now, okay? So now we've got come back to addition versus substitution. Okay, so just think about what would happen if those groups break off. So let's just say that there was what shall we use? Cn minus, right? If that happened, right, what would your first step be? Pause and do it yourself. Okay, now it would do it like that. And then the question is, if this left, right, is CH3 able to do this? And the answer is by no means. This is super unstable, right? It cannot stabilize itself by resonance, and because it's such a small atom, right, because carbon is such a small atom, you cannot disperse the negative charge across a large electron cloud. So the answer is no. Okay? So therefore, you will, if your thing is unstable, therefore it will produce this result. So I'm just going to erase that as, just going to put that as no, right? What's going to just happen instead is, right, you're going to get a H plus, which I'm just going to put here. And just mark it out with a tick, okay? Just mark that out with a cross as well. Okay, you're gonna have R, OH, Cn, and CH3. To be honest, if you're conducting it in the right solvent, I guess the sodium could be a counter ion, but never mind. It's okay. Whereas with substitution, let's have a look. So this is actually a really good leaving group. So how does that change, right? So pause and do the first step by yourself once again. Okay, now that you're back, it's going to be like that, and like that. Cl and Cn once again, right? So supposedly what would happen is this, right? And so the question here is, what's happened here, right? Why can the chlorine, so this chlorine can disperse the negative charge quite well because it's a large electron cloud. And so if this is stable, then you will favor substitution, okay? So this gets a tick from me, right? This is good, okay? Okay, next, we are gonna see the reactivity towards the nucleophile. Where is this? Have I jumped over something? Yeah, I think I kind of jumped over something. No, I haven't. Okay. So addition. So yeah, this is the same thing. So basically the leaving group ability is the ability to stabilize ability to stabilize itself after leaving, basically, and stabilize itself, right? Again, means induction and resonance. Okay, that's the key points for the first part.